Assalamualaikum and hi, my name is Ani Syahira binti Ahmad Kushairi. Okay, so I will be introducing my team members. Our first presenter is Tengku Muhammad Shukri. He will be explaining about the problem statement and objective of this project. And then Abdul Muiz bin Muhammad Nasir will be present about the design and simulation. And our last presenter will explain about the discussion and conclusion. Okay, so this project is mainly about small scale car. Okay, small scale car is a representative of a normal size car, and this small scale car are usually built as a toys for kids. Okay, nowadays there are small scale car or that can be controlled by using the remote control, or we call it as remote control car. Okay, usually this control car can be controlled the speed. Okay, we just can control the direction and then the brake. Okay, so in this project we will do a remote control car with variable speed. Okay, in this project we are using PI, okay, because the value of D is 0. So our presenter will explain the reason. And then we are using MATLAB Simulink as the software that can do the simulation of our project. So our next presenter will explain details about the problem statement and objective. Okay, thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Tengku Muhammad Shukri bin Tengku Ahmad and my matric number is AE180032.
Okay, Assalamualaikum warahmatullahi wabarakatuh. For the problem statement, to design the circuit for the small scale car in our project, we use MATLAB Simulink in order to design circuit and apply the DC motor and speed loop controller. As we know, DC motor consists of two parts, which is motor, stator and rotor, that help it to convert electrical to mechanical energy when they produce a continuous angular rotation that help to rotate the wheel of our small scale car. So in this circuit, in this system, we have to choose DC motor drive that will fit the system that will supply with voltage of 10 volt or less, or slightly less than that. Okay, then we also should have to determine the right controller in order to identify the right path with modulation, or in short form is PWN at the simulation. Okay, last but not least, we have to design a closed loop for the result output. Also, I have to mention that PWM are crucial because it controlling the drive of switching device, since it able to reduce the harmonics of the output voltage. Okay, that's all for problem statement. Okay, the objective of our study to develop speed DC drive for our small scale car model. Then we're also expecting to design a closed loop circuit, and last of our objective, in the end of the project, we'll be able to test and simulate the simulation of the circuit in the system by using MATLAB Simulink software. Okay, that's all for objective. Thank you.
Hi to everyone, my name is Abdul Muiz. I will continue to present about the design, simulation and result of our project. Stay tuned. Alright, first we use MATLAB software to design our simulation. Okay, based on our design of our project, we use closed loop motor control system. As we know, the closed loop system basically is open loop system with negative feedback. So the process of closed loop system is repeating and the error is reduced until desired value is achieved. So based on our design, the output of DC motor is being measured and feedback to the PID controller for error correction until desired value is achieved. So based on our project, the speed of shaft will measure and the feedback into the system to reduce the error. So we decide to slope because it is suitable for our circuit. Okay, for the next principle, if we use DC motor here, so as we know, DC motor is dividing into mechanical and electrical part that's work by generating rotational motion from electrical energy connected to it. So as we know, the DC motor have four main type, which is permanent magnet, series, shunt, and wound DC motor. So a direct current source is connected across the stator and rotor. So from this DC motor, when we include DC motor here, we click here. We need to adjust the motor parameter here. We click parameter here, and so for the first step, we will change this value. The resistance is 2 ohms, the inductance is 0.00545 Henry, the torque constant is 0.2, the total inertia is 2.93 exponent negative 5, the recourse friction coefficient is 11.7 exponent negative 5, and the initial speed is 1 radian over second, and then we click OK. Okay, the next principle is we use PID controller. Okay, as we know, the PID controller is the most common type of feedback control being used to provide its simply method and flexibility of use in the process control. Okay, the performance of PID controller is depend by the heavily on tuning of its KP, KI, KD parameters, as poor tuning result in high rise time and settling time, large overshoot, and high steady state error. Okay, so for our PID controllers here, to adjust the parameter value of KP, KI, and KD, for the first, I need to adjust the time first, 1/400 here, and then to get the we had used auto tuning here to get the precise parameter tuning for KP, KI, KD to produce more stable response of our signal here. So we click auto tune here, and then the result we give the step response of our PID, and then the value of PID will display here. The suitable value of our PID will display for our project. So the value of KP is 8.1274 exponent negative 0.6. The value of I is 0.006519. The value of D is 0. Okay, why value of D is 0? We will explain in our discussion later. Okay, for the next is what you want to do is we need to adjust this value, put the value here. For KP is 8.1274 exponent 0 negative 0.6. The value of KI is 0.006519 here. We click OK, and we click to run the simulation. We click run. We click run here. Okay, we need to wait for the result. Okay, for the result, first we see the RPM of the motor here. This is the we will get the RPM of the motor. Okay, this is our graph of RPM of the motor, and the next the graph, the result of armature current of the system is here. This is armature current of the system. We will explain in our discussion later. And then the next is field current of the system here. Okay, 0. And then lastly, for the motor of torque here. This is our graph of the motor torque here. Okay, that's all for the simulation design and our result.
Hi, my name is Aimirauka binti Abdul Razak with the metric number AE180001. So for my part, I will explain about the discussion and conclusion. For the discussion part, we will start with the armature current of system, where we from the graph we can see that when the time is rising gradually in x-axis, the current value become constant throughout the time taken, with the value of slightly higher than 0.5 ampere. For the speed RPM of the motor graph, when the speed is below 0, the current will be equal to 0, which indicates that the device hasn't on its starting point yet. But when the speed is equal to 0 and increase gradually, the current escalate but remain constant when it's reached certain value. For the third graph is field current graph, where the current becomes 0 and stay constant throughout the time taken for the simulation. This is possible since permanent magnet motor has been used. Permanent magnet motor is more efficient and make a fully use of magnet than field windings. For the last graph, which is motor torque, the value of torque become constant where the value is higher than 0.1 Nm with the increment of time. The motor torque is a special brushless permanent magnet, or we can call it as direct drive, that can produce torque even when device is at stationary. High starting torque can be gained because of proportional integral derivative or PID controller that can calculate errors value with high accuracy. The gain The value of the gains can be obtained by auto-tuning method in the MATLAB simulating software. The proportional gain Kp can be used to improve the transient response rise time and settling time, while the integral gain Ki is to improve steady-state response. The derivative gain Kd is to gain the transient response, but by predicting error will occur in future. But from our simulation, the value of Kd has been set to 0. This is because the value of D, if the value of D is more than 0, it can amplify the frequency of noise if the system is at steady state. Hence, the D was set to 0 to keep the system stable and optimize the problem. All parameter details and step response figure can be seen in our full report. The last part of our presentation is conclusion. This project has helped us to gain more knowledge and improve understanding in this particular subject, which is electrical drive. The second one is the process of designing closed-loop motor control system also can be learned through MATLAB simulating software. Application of the closed loop can be clearly seen as in our project we use in small car model by using DC motor and PID controller. The closed loop system meant to enhance the stability of the system. And the last one, by implement this project, we can experience how to work in team and learn to accept others' opinion. That's it for conclusion and our presentation. Thank you.